A very good morning, everybody. Welcome back to my YouTube channel. It's me, Liana, again. Now I'm in third sem doing my engineering at Sri Venkateswara College of Engineering. Today's subject is digital design and computer organization. And today's topic, I'll be dealing with concepts of K-map, advantages and its disadvantages. So let's start this session. Now, what is K-map? K-map is also called as Karnaugh map. It refers to a pictorial method that is utilized to minimize various Boolean expressions without using the Boolean algebra theorems. So it's a type of minimizing the logical algebraic expressions. Now here this is the special version of the truth table. Karnaugh maps are used to simplify real-world logic requirements so that they can be implemented using the minimal number of logic gates. So given below is an example of how we represent a K-map. Coming to the types of K-map, there are two types of K-map. There is two-dimensional K-map and three-dimensional K-map. A two-dimensional K-map is the most commonly used K-map. Now here in two-dimensional grid of cells are arranged in form of rows and columns, just like a matrix. So each row represents combination of inputs and each column represents one variable of the input. Three-dimensional K-map is a type of K-map used for optimizing Boolean functions with 5 or more variables. It adds an additional dimension on the grid. Now each level of the cube represents the combination of two input variables, while third variable is represented by the position of the cells inside the cube. A Karnaugh map can take two forms, that is the sum of product and product of sum, that is called as SOP method and POS method, that we use for minterm and maxterm, that we'll learn in the later slides. So these are the examples of Karnaugh map. This is a 3-variable K-map and the next to it is a 4-variable K-map. There is also 2-variable K-map which I didn't put it in this. Now this is an example for minterm expression, that is SOP method, and next to it you can see A plus B, C plus B, that we represent for a maxterm expression, that is POS, product of sum. Coming to the concept of K-map, grouping. After the Karnaugh map is being constructed, it is used to find one of the simplest possible forms, a canonical form for the information in the truth table. Now the adjacent one in the Karnaugh map represent opportunities to simplify the expression. So they are called as the minimal terms. For the final expression are found by encircling groups of ones in the map. Minterm groups must be rectangular and must have an area that is a power of 2, that is 1, 2, 4, 8. Minterm rectangles should be as large as possible without containing any zero. Group may overlap in order to make a larger one group. So the same condition can also be applied for maximal terms. So they use the product of sum condition. So let's discuss the rules for grouping. Now rule 1, we can either group zeros together, zeros with zeros, ones with 1, but the zeros and 1 cannot be grouped together. Now X represents don't care condition, so it can be grouped with zeros as well as ones. Now rule 2, groups may overlap with each other. So as you can see in the picture given next to it, it can be grouped together. It can overlap together, just as in the second condition it's given. Now rule 3, we can only create a group whose number of cells can be represented in the power of 2. In other words, a group can only contain 2 to the power n. That is 1, 2, 4, 8, 16 and so on number of cells. Like that we can make it into a 2-variable map, 4-variable map, 3-variable map, and the list goes on. Now rule number 4, groups can only be either horizontal or vertical, and we cannot be created groups of diagonal or any other shape. So diagonal is not allowed, only horizontal and vertical. Now rule number 5, each group should be as large as possible. That means that the grouping can be done in octa form, in quad form, then comes dual, then comes individual. So first always when you're grouping, always try to see whether you can make an octa. Then go for it. Then last you should go for the individual cell options. Next one, rule 6. Opposite grouping and corner grouping are allowed. The example of opposite grouping is shown illustrated in rule number 5. Example of corner grouping is shown below. So for example, this second picture where you can see here, this thing can be considered as a quad group because whenever you fold a roll of paper, those two will come together. That means they can be grouped together, so they can form a quad. So that's why we consider those two and they form a quad. Rule number 7, there should be as few groups as possible. So for example, this thing, so in the second picture you can see in the corners there's 1, 1, 1, 1. Those 4 things can be grouped together as a quad because when you, as I told you, when you roll it into a sheet, it gets grouped together, it joins together, so that's why it forms a quad and you can start your grouping. Coming to the example for k-mass simplification. Now here this is the question, that is f to, in brackets, a b c d is equal to min term 0 1 2 5 7 8 9 10 13 and 15. Now here min term we are always going to represent by 1 and max term is for zeros. Now here we are going to put 1 in 0th position, then 1th position, then 2th position, then comes 5 7, then 8 9 10 13 15. Like this we fill in the numbers according to the question. Then after that we start grouping them. So we go for the higher number of groups where you can form. So this is the first group which is formed, that the blue one where you can see. Next comes the orange, then comes green. That green also forms a quad, as I told you before. When you roll it, it will form, it joins together to form a group. So this becomes a quad. Now now we'll take the representation. For the first group, it will be a complement b plus ab. Then after that into c complement d plus cd. Now since we know that a complement and a gets cancelled, so left is b, and d complement and d gets cancelled, so left is bd. So the first group is bd. Next one is plus a complement b complement plus a complement b plus ab complement into c complement d. Now this entire thing, it gets cancelled because you know a complement is there and a complement and a gets cancelled, so this entire term is not there, so the remaining is c complement and d. Next one is a complement b complement plus ab complement. So a complement and a gets cancelled, so left is b complement, and c complement and c gets cancelled, left is d complement. So we have our equation as b complement and d complement for the third group. So therefore our minimized boolean expression is bd plus c complement d plus b complement d complement. Coming to the advantages of k-map. So now here in this k-map, they do not need to know the basic Boolean algebra rules. Second thing is they provide a visual and intuitive way of finding patterns and groups in logical functions. They can handle don't care conditions, which are cases where the output value does not matter for some input combinations. Let's discuss about the disadvantages of K-map. So they become difficult and impractical to use when the number of input variables exceeds 4 to 5. They may not always yield a unique or optimal solution depending on how the regions are formed and selected. They might not eliminate all possible race hazards, which are situations where changes in input values cause unwanted changes in output values due to different propagation delays in logic gates. Now we have reached the end of the slide. Thank you for watching. Please do like, share and subscribe. So that's it for today. Come